Very good morning, students. So, welcome to IIT JEE Foundation Program or Focus C by Krishnaveni Talent Schools and the Mastermind Schools. So, once again, I welcome all the class 7th students for today's session. As you can see on the screen, and you're all well aware, my subject is physics. We are in class 6th. Our ongoing chapter, that is the second chapter, Kinematics. And today we are entering into the session number 2. Means we started this class in the last session. When we are taking the last class on Tuesday, we started the kinematics after completing units and measurements, right? So in the day 1, in the first class, we discussed about the what is kinematics and what is motion, what is rest, and what are the different types of motions which will come across in our day-to-day life, right? So we'll continue where we left in the last class. But before that, just recall what we learned. So just recall them and then we'll move to the today's class anyway. So when you recall them, first we learn about what is kinematics. As you all know, kinematics is a branch of mechanics. Kinematics is a branch of mechanics which deals with the motion of a body. Deals about the motion. It deals only about the motion, not about the cause. Right? So then when you come to the before knowing about motion, you should come to study about the rest. When a body occupies same position for a long time, it is said to be at rest. Suppose body changes the position from time to time, then you can call it as in motion. Right? So rest and motion are relative terms. When a body is in motion, we cannot say it is at rest. When body is at rest, we cannot say it is in motion. Both are relative. Rest, motion. So they are compared with respect to time and surroundings only. Then we are seeing there are various types of motions are there, like translatory motion, rotatory motion, vibratory motion, circular motion, random motion, and many types of motions we discuss with the various examples. So these are the things what we've done in the last class. But what we are going today we are going to know about when a body is in motion. Suppose body is moving, right? When body is in motion, so definitely it will cover some distance, right? Distance, or it is also called, other word is displacement. So every moving body covers distance or displacement. It has some speed or velocity, right? It accelerates, that is increases or decelerates. Means increases the velocity or decreases velocity. And of course, time is a very important. Whether body is moving or rest, time will come to me. So these are the terms related to motion of a body. So after knowing about the motion, when a body started moving, what happens? Every moving body will cover some distance or displacement. It has some speed or velocity. It accelerates or decelerates and takes some time. So we should know about all these things in details. What is distance? What is displacement? What is the difference between them? What is speed? What is velocity? What is acceleration? What is deceleration? Of course, what is time? We already seen the measurements. But here we are discussing about the during motion what happens. Right? When the body is in motion, how come these terms comes into play? So in the first, distance and displacement. We are discussing about the distance and displacement, right? So what is distance? You can see clearly. Defined as the length of actual path followed by a body as it moves. Suppose two destinations are there, A, B, right? A body from A to B like this goes. Right? This total path, the entire path is called as a distance. Suppose if you go directly like this, A to B, this is called shortest path. So for one place to another place, we can go by various routes are there. There is a shortest route may be there, there is a long route may be there. But entire path forward is called distance. The shortest path is called displacement, right? It is measured in meters and centimeters. Meters in MKS or SI, centimeter in CGS. Or sometimes, okay. Now, distance traveled by a body never decreases with time, right? Distance never decreases, means dexter cannot be negative. The distance traveled by body can never be negative. It is a scalar quantity, means it has only magnitude, no direction. It cannot be negative. It cannot become zero. Distance cannot be zero, cannot be negative, and is a scalar quantity. Clear? Now, second, the shortest path. So, magnitude of displacement is the shortest distance between the 2 points. From one point to another point, which distance? Suppose somebody asks you, where is your nose? We can show like this also. We can show like this also. So, this is the displacement showing like that is distance. That's all. Simple funda. Okay. So, it is a vector quantity because displacement will have specific direction. And for moving body, it can be positive, negative, or zero. Displacement can be zero also. Example, I will see here. So, you are at home, right? This is school. You started moving from home to school. You came to school and you observe that, say that is 2 kilometers from house to school. So you walk 2 kilometers and after coming over school, you came to know that school is holiday. So what will do? You'll go back another 2 kilometers. So the distance traveled by you is 2 kilometer plus 2 kilometer, right? Distance is total path. That is 4 kilometer. But what is displacement? As you came back to original point, the displacement is zero. Right? Suppose you hire one car. He came to your house to pick you. You moved throughout city and you came back to home by evening. So don't say that your displacement is zero, I won't pay the money for you. He won't accept. As per the physics, that is correct. It cannot be applied practically. So your displacement is zero even though distance is 4 kilometers. Why displacement is zero? Because you are there at the same point where you started. That is, initial and final positions are same. Whereas the total length of the path can be taken as a distance. So you have to pay the anything according to distance only, not according to displacement. Right? So the shortest path is called displacement. Simply shortcut. Shortcut from initial position to final position is called displacement. Okay. And some more information is there about displacement. Even different shapes also you can see mathematics. So displacement is the shortest distance between initial point and final point. So many ways. See, you are moving from here, right? You can see how they are moving. Simple examples, figures are given. From this tent house to here, like that, move totally 200 meters. This is called distance. But when you go directly from here to factory, it becomes only 120 meters only. So that is shortest method. Okay. So distance is always greater than displacement because displacement is shortest, but sometimes equal also. One case there is equal. In one case, both distance or displacement is same is straight line. Suppose body moves from A to B 2 kilometers. So what is the distance? 2 kilometers only. Displacement of the straight line also same only 2 kilometers. So distance is equal to displacement, only one case when a body moves in straight line. Remaining all cases, distance is more than displacement. Right? So the magnitude of displacement of the body is always less than or equal to the distance. Distance is a scalar quantity, displacement is a vector quantity. The displacement of the body has zero, positive, negative, but distance always positive. The distance, why distance always positive? Because it is not having the direction. It is a scalar quantity. The distance traveled by a body can never be zero also. If the object travels along the following paths, so different shapes are given as per the path, you can identify what is the distance and displacement in the following cases, right? You can see here. So different path body is following here. See, first, body travels from A to A, means started from A, it moved like this. A from here, again came back to A. So how many years are there? 4 years. A is the distance. Distance is 4A. A plus A plus A plus A. Right? Whereas as it came from A to A again, initial position, final same, displacement is 0. Second case, body travels A to A in circle. It started from here, it travel again to A. That is circumference. Circumference circle is given by 2 pi r, total distance. But again, displacement is 0 because body came back to A. So it is semicircle, travels from A to B. So A to B is the arc of the circle. Half of the circumference, that is 2 pi r by 2 pi r. Distance. What is displacement? A to B. A is one radius, other is radius, 2r. R plus R. Right? Body travels A to B. These are 1/4 of the circle. 1/4 means 2 pi r by 4 you have to do. Pi r by 2 is the distance. From here to here, pi r by 2. But only displacement you have to take this. AB square is equal to AC square plus BC square. As per the Pythagoras theorem, root 2r. Right? Body travels from A to B. A is there to B. A to B. So, distance traveled is A only. A to B, sorry. Straight line. When body is in straight line, distance and displacement are same. Body travels from A to B again here. So, again this is AC square is equal to AB square plus BC square. Under root of A square plus A square. Under root of 2A square. Okay, root 2 A square is can take out. Whereas distance is A only, 2A because A. So like that for every path of life, the total path, total length of the path followed is called distance, and the shortest distance is called displacement. Distance is always positive, it cannot be negative or 0. Whereas displacement can be positive, negative, or even 0 also. Okay. So before going for that, let's just have one video on this. Then we'll move to the next part. Okay. Distance and displacement. We'll move to the next one. Just
look around yourself and you will find objects of different kinds such as television, mobile, trees, cars, buses, trains, etc. Objects such as television, mobile, trees, etc. are static. In other words, their position does not change with time. Such objects are said to be at rest, whereas objects such as cars, buses, trains, etc. are non-static. It means that their position changes with time. Such objects are said to be in motion. Let us discuss motion and time in greater detail in this lesson. Objectives. At the end of this lesson, you will be able to differentiate between slow and fast motions, define speed, measure speed, identify the units of speed, measure time. Suppose you have an appointment with your doctor at 5 in the evening. It is already 4:30 p.m. and the doctor's clinic is 5 kilometers away from your house. You have the choice of either cycling down or taking a taxi to the clinic. What will you do? Correct. You will take a taxi because a taxi is faster than a cycle. So we can say that some objects move faster than others. Now the same taxi moves fast on an empty road and slow on a busy road. Thus, the same object can move fast at one time and slow at another time. The next step is to identify whether an object is moving faster or slower than another object. To do that, you must calculate the distance covered by both the objects in the same time interval. Consider a 1,000-meter cycle race. When the whistle blows, the race begins. Every cyclist starts at the same time. Suppose after 10 minutes, one cyclist reaches the finishing line. This means that the winner covered the distance of 1,000 meters in 10 minutes. This also means that all the others who reached the finishing line later covered less than 1,000 meters in 10 minutes and hence lost the race. So we can say that the object that covers a longer distance in a given time interval than other is faster. The most convenient way of finding out which object moves faster than the others is to calculate and compare the distances covered by all the objects per unit time. The object that covers a greater distance per unit time is quite obviously faster. The distance covered by an object per unit time is called the speed of the object.
That is our next topic.
Suppose your brother claims
Speed
that
and velocity.
his motorbike is faster than his friend's. His friend denies. You know that your brother's motorbike covers a distance of 60 km in an hour, whereas his friend's bike covers 40 km in 1 hour. Let us now check the claims of your brother and his friend. The speed of your brother's bike is 60 km per hour, and that of his friend's bike is 40 km per hour. Your brother's bike is certainly faster than his friend's because its speed is greater. To measure the speed of an object, we measure the distance covered and time taken to cover that distance by the object. After that, we apply formula of speed. Let us learn to measure speed with this simple exercise. Draw a line. Ask a friend of yours to stand on the line. Allow him to run till he wants to stop.
Speedometer
Note the
with their
total time
vehicles.
taken from the moment he started to the moment when he stopped. Measure the distance covered by your friend. Now divide the distance covered by the time taken to cover the distance. What you have calculated is the running speed of your friend. Do the meters and indicators in front of the driver's seat of your father's car scare you? Now they won't. Straight beyond the steering wheel are 2 meters. The circular dial, which looks somewhat like a clock with needles and numbers, is the speedometer. When the car is in motion, one needle points to a particular number in the speedometer. This number is the speed of the car in kilometer per hour. There is also a rectangular box within a speedometer that has digits written on it. When the car is in motion, these digits undergo a change, rather increase. This rectangular box is known as the odometer. Its readings show the distance covered by the car. Have you ever wondered how our elders could tell the approximate time of the day by just looking at the shadows? Many events in nature repeat themselves after
Okay,
definite...
it's about the time we'll discuss in the next class. So clearly here you can see that. You can clearly see what is the distance and displacement followed by the speed also explained here. See, there is a differences are there between distance and displacement. You can see clearly, right? So when you see distance, so just a minute. So distance is the complete length of the path between the 2 points is called distance. Displacement is the direct length between the any 2 points when they measured along the minimum path between them. Distance is denoted by D, displacement is by S. To calculate the distance, the direction is not considered. So to calculate the displacement, the direction is taken consideration. Distance is scalar quantity, displacement is a vector quantity. Distance gives the detailed route information that follows while traveling from one point to another. As displacement refers to the shortest path. Distance is given by speed into time. Displacement is nothing but velocity into time. The distance can only have positive values. Displacement can have positive, negative, and even 0 also. Distance is not indicated by an arrow. Displacement is indicated by arrow. Arrow indicates the direction, which direction it is going, whether north, east, west, south. The distance can be measured along the non-straight path. Displacement only measured along the straight path. Distance depends on the path. It changes according to the path taken. Displacement does not depend upon the path. It only depends upon the initial and final position of a body. See, the two simple terms have huge number of differences. 10 differences we found between one. Even you can write distance is always more than or equal to displacement. Displacement is always less than or equal to distance. 11 points for the simple terms which are sound same. In regular life, both are same only, but only when you come to physics, we can see that we can classify them into scalar and non-scalar. That is vectors. Right? So when body is in motion, distance and displacement will come. Next comes is even we can come across after distance and displacement, we will come across the speed and velocity also. So which are also connected to same terms. So speed and velocity. Okay. So what is the difference here? Speed is nothing but distance by time. Velocity is nothing but displacement by time. That's all. Distance by time and displacement by time. So speed is a scalar quantity, velocity is a vector quantity. But there are different types of speeds are there, like our uniform speed, non-uniform speed, average speed, instantaneous speed. Okay, types of speeds. So first we'll see what is the speed here. When you see here, the speed is the distance traveled divided by time. That is, this speed is equal to distance by time. Okay, it is a scalar quantity as it is a magnitude but no specific direction. Units are meter by second because distance is measured in meter, time is measured in second or centimeter per second. Or largest units are kilometer per hour also. We can measure big distances, big speed when you go, when you see in your vehicle, two-wheeler or four-wheeler, we can find the speedometer. The speedometer measures the speed in kilometer per hour only. So what is kilometer per hour? So kilometer per hour you can convert into meter per second also. So what is kilometer? 1 kilometer is equal to 1000 meters, right? By 1 hour is equal to 60 into 60 seconds. Because 1 hour is equal to 60 minutes, each minute is equal to 60 seconds. So total 3600. 1000 by 3600 meter per second. So 0 zeros cancel, 2 zeros, 2 fives are, 2 18s are. That is 5 by 18 meter per second. 1 kilometer per hour is equal to 5 by 18 meter per second. Or 1 meter per second is equal to 18 by 5 kilometer per hour. Very, very important conversion even in the IIT exam also. Right? 5 by 18, 18 by 5. If you want to convert kilometer per hour into meter per second, we have to multiply with the given number with the 5 by 18. If you want to convert meter per second into kilometer per hour, you have to multiply by 18 by 5. That is the largest unit of speed. The speed is measured when it is a very long speed. Small, you can measure in meters and centimeters only. Right? So when you come to the types here, types of speed, I told all uniform speed. Uniform is constant. It is also called constant speed. Suppose from your house to school, total 2 kilometers distance, right? This is your house, this school. So make it as half distance, 1 kilometer and 1 kilometer. You started from 8:22 from here, right? So 1 kilometer you covered 8:30, you came here. 8:40 you reached the school. Means 1 kilometer you covered in 10 minutes. Second 1 kilometer also you covered in 10 minutes only. So what you can say? You are moving with the uniform speed. If body covers equal distance in equal interval of time, then you can say a body is moving with the uniform speed. The figure is given, see here. Every 5 minutes, 5 meters. First 5 meters, second 5 meters, 5 meters, 5 meters, 5 meters. Every 5 meters is covering only 1 second only. Okay, that is moving with the, because you know the speed is nothing but distance by time. Distance is 5 meters, time is 1 second. Every time you can find 5 meters per second only. That indicates clearly that body is or vehicle is moving with the constant speed. That is called uniform or constant speed. Clear? So opposite that is non-uniform speed. See here, 5 meters is covered in 1 second. Next, in 1 second, he covered 8 meters. Next 1 second, he covered 10 meters. Next 1 second, he covered 4 meters. Next, again 6, again 7. So, every 1 second means he's covering the unequal distances, equal interval of time. For every 1 second, he's changing his speed. That indicates that it is a non-uniform or variable speed. Speed is varying. Varying means changing. So you can call it as non-uniform or variable speed. The body covers unequal distance in equal interval of times or equal distance in unequal interval of times is called as non-uniform or variable speeds. Right? Again, we have one more is there. Average speed. So suppose a body is changing, not uniform, it's continuously changing time to time. Then average can be calculated by total time, total distance by total time. Total distance by total time. Like that we can calculate the average speed. So like that we have instantaneous speed. That average speed, the special cases are there, is no need for us. So see, that is the odometer, speedometer is their vehicle. Suppose you are traveling with some speed. You can see your odometer, the speedometer, you can tell at any time what is speed you are going. The speed of a body at any instant of time, which is measured by a meter, is called instantaneous speed. A speed at any instant of time. Okay. Then same velocity also. Velocity is nothing but in place of distance, you have to write the displacement. Velocity is nothing but displacement by time. That is uniform velocity, non-uniform velocity, instantaneous velocity. Just a conversion I told, na? Conversion from kilometer per hour to meter per second. Right, that already there. Then when you see the differences here, I'll show you difference between the speed and velocity here. It's not so clear maybe. So speed and velocity also have a lot of differences like distance and displacement. Okay, it's not clear. Later I'll show. Okay, so velocity is also defined same. The rate of displacement or displacement by time. It may be either velocity, uniform velocity, covering equal distances, non-uniform velocity, instantaneous velocity, and finally you can come across the conversion. How to convert the kilometer per hour into meter per second. Already I told, I explained you also. 5 by 18. So 1 kilometer per hour is equal to 5 by 18 meter per second, or 1 meter per second is equal to 18 by 5 kilometer per hour. Very, very important. For example, they give 54 kilometer per hour is equal to dash meter per second. You can find so many problems. So kilometer 54 into 5 by 18 you can write. 18 ones are 18, 3s are 5 3s are 15 meter per second. Simple. So many problems based on this only you get to come across. Any level, level 1, level 2, level 3, every problem you can have the such kind of problems. Just converting from kilometer per hour to meter per second or meter per second to kilometer per hour plays very, very important in any competitive examination. You can simple, just for example, I tell, before going for the next topic, that is acceleration. A bus traveling with a speed of 72 kilometer per hour. How far does it travel in 2 seconds? See, he's not given the hours. He's asking for in seconds. So definitely when he's asking in seconds, you have to convert the kilometer per hour into kilometer per hour should convert to meter per second. So that is speed is equal to 72 into 5 by 18. 18 4s are 72. 4 5s are 20 meter per second is the speed. And time is 2 seconds. So bus starting the speed and how far distance you are calculated. So speed is equal to distance by time. So distance is equal to speed into time. So speed is 20, time is 2 seconds. That is 40 meters. Answer is C. So speed is equal to formula distance by time. SI unit of speed meter per second. Simple. Convert 1 see very important. Convert 108 kilometer per hour into meter per second. So 108 into 5 by 18. 18 maybe 5 is a 8 is 6 a maybe. 8 is 6 a. Right? 5 6 a 30. 30 meter per second. Right? So covering a large distance in short time. Covering a large distance in short time is called high speed. To go to, because the distance is large, na? We cannot say low speed or cannot say zero speed. So like that you can solve all the questions if you are perfect in the concept. That's why I'm explaining maximum concepts only. You have to practice these levels in your notebook. If you have any queries, we have given the solutions also for each and every problem. So this level 1 is there. Not only answer, we give the solutions also. So this very, very important. 15, see one more example I tell. Just here some difference is given. Meter per second into kilometer per hour. Right? 15 meter per second into kilo. 18 by 5 you have to do. 5 3s are 15. 18 3s are 54. So 54. So almost all the problems based on same only. You need to convert the one into another unit so that you can solve any kind of problem in a playway method, right? So these are the two topics what we discussed today is whenever body is in motion, distance and displacement, speed and velocity. So in next class, we'll discuss about acceleration, negative acceleration, right? And types of accelerations followed by some equations, which are called equations of motion, right? Okay. So yeah, today we are very much clear about the what is distance, displacement and speed and velocity. So that's all for today. Have a wonderful day. Thank you, students.